Quantitative analysis measures the amount in terms of mass of product made in a chemical reaction. Reagent. Reagent is just another word for substance. But limiting reagent applies to a reactant. So we're talking about stuff on the left-hand side of the arrow, our starting materials. So the limiting reagent is the reactant that gets all used up in the reaction, and you've run out of room, but there's more. It's the reactant that gets all used up in the reaction, therefore limiting how much product is made. So once all your limiting reagent is used up, you stop making product because you have nothing building it. Okay, you've run out. Excess reagent, on the other hand, is there in larger amounts than needed. So it's the reactant that does not get used up. Bless you.
Hello.
So the first step, just like we've been doing, we have to balance our equation. Then what you're going to do is take your mole ratio and convert your moles of propane to moles of oxygen. This is the only place you use these red coefficient numbers. That's it. Do not multiply your molar mass by those numbers. So 4 moles of propane, and we want oxygen. So oxygen's going to go on top. Propane goes on the bottom. So moles of propane cancel. So minimum, we need 20 moles of oxygen. That's minimum. If we want 10% extra, we have to add that. So there's 2 ways to do this. You can say 20 moles of oxygen times 10% is 2 moles. So I need a total of 20 plus 2. Or I need 110%. So I take my 20 moles and I times it by 110%, and I don't have to add anything because it's built in. So this is what we know to start with. We know the mass of sodium, we know the molar mass of sodium, We don't know chlorine, but we want 10% excess when we do calculate it, and we know the molar mass of chlorine. It's balanced. We can start. So we can find moles of sodium. So I'm going to do formulas first, then I'll do dimensional analysis. So moles is mass divided by molar mass. So 0.5 divided by the molar mass gives us 0.021748 moles of sodium. So we need to convert from sodium to chlorine. So we need our mole ratio. There's 1 mole of chlorine for every 2 moles of sodium used. So if I take that number and divide it by 2, I get moles of chlorine. So if I take 0.010874 moles of chlorine, multiply it by the molar mass of chlorine, we get 0.770967 grams of chlorine. So this is what we would normally calculate. This does not include any excess. So you need to throw in a little bit extra chlorine. So if we take this answer and times it by 1.10, we'll have the total mass including the mass of the 10% extra. So if you multiply that by 1.1, you get 0.85 grams. Now I have a question for you. Does it matter at which step you multiply by 1.1? Think? So if I multiply 2 times 3 times 4, I'll get a different answer if I do 2 times 4 times 3. No. So it doesn't matter where you multiply by 1.1 as long as you do. Okay? So dimensional analysis. Because we want grams of chlorine, we have to start with a molar mass of chlorine because that contains grams of Cl2. So we start with the molar mass of chlorine. I want to get rid of the moles though, because I only want grams of Cl2 in my final answer. So if I multiply it by my mole ratio, I get rid of moles of chlorine, but I introduce moles of sodium. To get rid of my moles of sodium, I need to use my molar mass of sodium because it has MOL-Na. Now I've gotten rid of my moles of sodium, but I've introduced grams of sodium. Got to get rid of those. So I'm going to multiply by 0.50 grams of Na. Normally, this would be where we stop because We now have the units that we want, and only those, but I need excess 10%, so I'm going to multiply it by 1.10 at the end. And you should get 0.85 grams of Cl2.